Hey guys, so today we're going to be talking about solving equations that involve logarithms. And there's 4 different types that we're going to talk about. Our first type is if we have exponentials equations without a common base. And as some useful information, you will need a calculator today. So make sure if you don't have a calculator, pause the video and go get one real quick. All right, so number 1. Let's look at 3 times 5 to the x plus 5 equals 17. Now, our goal when we're solving these exponentials is to get this 5 to the x by itself. So to do that, the first thing I'm going to do is subtract 5 from each side. And then I need to get rid of the times 3 in front. You cannot multiply these together because the 5 has an x. So to get rid of the times 3, we're going to divide each side by 3. So we get 5 to the x equals 4. Now what we were able to do previously is to rewrite these with the same base to set the exponents equal. Now here, 5 to the x, 5 can't be written as a power of 4, and 4 can't be written as a power of 5. So here, what we're going to have to do is write this in log form. So here, when I do this, it would be log. 5 is the base of our exponent, so it's the base of our log. So log base 5. And then we switch the next 2. So this would be log base 5 of 4 equals x. So here, the left side just has numbers on it. Log base 5 of 4, our x isn't over here. So what we can do is use the change of base formula and put it in our calculator. So the change of base formula for the left-hand side would then be log of 4 divided by log of 5. And when we stick this in our calculator, we should get 0.861 equals x. We'll round to 3 decimal points. So I'd like you to try 2 and 3. Try 3 to the x equals 30. And 10 to the x minus 4 equals 34. So go ahead and pause this video and try these 2 problems. All right, check your answers for 2 and 3. So in 2, the exponent was already by itself, so we could go ahead and write it in log form. And then once you write it in log form, you can use the change of base formula, so we can stick it in our calculator. Now 3 is very similar. All we had to do first was add 4 so that the exponent, the 10 to the x, was by itself. Then we could write it in log form, use the change of base, and stick it in our calculator. All right, so that's type 1, when they're exponentials and we cannot get the same bases. The second type of equation that we could have involving logarithms is when we have logs on one side of our equation. So it'd be something like log of something equals a number. All right, so let's take a look at what this might look like. So let's do 2 times log base 2 of x plus log base 2 of 5 minus 1 equals 7. So the first thing that I kind of want to do here is this inside parenthesis, I can combine these logs using our laws of logs that we did previously. So whenever we're adding these logs, this means to multiply. So I'm going to multiply x and 5 together. So when I do this, I get log base 2 of 5x minus 1 equals 7. Now, similar to how we wanted to get the exponents by itself in the previous type, here we want to get the logs by itself. So to get this log by itself, I'm going to first add 1 to both sides, which would give me 2 log base 2 of 5x equals 8. Now from here, we could use this 2 and bring it up as an exponent. However, it would give us smaller numbers if we just divided both sides by 2. So I get log base 2 of 5x equals 4. So now here, once we get to a log equals a number, or log equals a single term, we can go ahead and write this in exponential form. So the opposite form of what we just did. So here, 2 is the base of my log, so it's the base of my exponent, and then we switch the next 2. So this would be 2 to the 4th equals 5x. Well, 2 to the 4th is 16, so 16 equals 5x. Divide each side by 5. So 3.2 equals x. All right, so I'd like you to try these next ones. So go ahead and pause the video and try these problems. All right, check your answers. So all of these were already in exponential form, or excuse me, in the form of a log equals a number. So I went ahead and write them all in exponential form. So here, 7 squared equals x. Remember 7, and then you switch the next 2. Here, 2 to the x equals 64. Well, 64 is 2 to the 6, so that means x has to equal 6. Now here, this x minus 9 has the same properties of this 5x. So we can't just like divide by 5 because it's inside the log. Same thing, we can't add 9 because it's inside the log. So we'll write it in exponential form. This will be 2 to the 4th equals x minus 9. And 2 to the 4th is 16. And then we can add 9 to each side. Right, so that's our second type, is with logs on one side of the equation. Type 3 is when we have logs on both sides of our equation. So logs on both sides of our equal sign. So it should look something like a log equals a log. And our goal when that happens is to rewrite it like that so we can drop the logs. So let's look at 8. 3 log of 2 plus log of x equals log of 24. So our goal, or what we want to do, is to condense these logs into a single logarithm. So we want to use our rules or our properties of logs. So first I look for numbers in front that can go up as exponents. So 3 goes up as an exponent on 2, so that this will become 2 to the third. Well, 2 to the third is 8. So this is log of 8 plus log of x equals log of 24. So now I still have 2 logs on the left, so I need to condense them down. So when we're adding logs, this means to multiply. So I'm multiplying 8 and x. So this would give me log of 8x equals log of 24. Now, whenever we get a log equals a log, we can drop the logs because it's like having the bases be the same. So if they're both logs, that means whatever we're taking the logs of has to be equal. So 8x has to equal 24, which means x has to equal 3. I'm going to have you guys try 9 and 10. So 9 will be log base 7 of 3x plus 5 equals log base 7 of 8x minus 12. And 10 will be log base 2 of x equals 2 log base 2 of 3 plus log base 2 of 5. And I'll go ahead and tell you what these answers should be, and then you should go ahead and try them. So we should get for 9, x equals 3.4. And for 10, we should get that x equals 45. So go ahead and pause the video and try these problems and see if you can get them. All right, and here's the work that goes with these two problems. So on 9, we already had a log equals a log. So we can go ahead and drop those logs. So we have 3x plus 5 equals 8x minus 12. And then now this just becomes a normal linear equation that we're solving with one variable. So we get our x's on one side, our numbers on the other, and then divide. Now on 10, we had 2 logs on the right-hand side, so we need to condense these down. So first thing I did is this 2 in front, I moved it up as an exponent. So 3 squared is 9. And then I combined the addition between the logs, means to multiply. So I multiply 9 times 5 to get 45. And now we have a log equals a log, so we can drop the logs. Now I'm going to do 2 more in this type, and they're just a little bit more complicated, so I didn't want to make you guys try them. So number 9, let's do log base 7 of x plus log base 7 of x minus log base 7 of 3 equals log base 7 of 12. So here, I want to condense the logs on the left-hand side first. So adding means to multiply, and subtracting means to divide. So I'm multiplying x and dividing by 3. So I would get log base 7 of x squared divided by 3 equals log base 7 of 12. Now we can drop the logs. So x squared divided by 3 equals 12. And then we're solving for x. So I'm going to multiply each side by 3. To get x squared equals 36. And then I'll take the square root of each side. So we get x equals plus or minus 6. Now remember, you cannot take the log of a negative number. So if I was to get x equals negative 6 and plug it in, I'd be taking the log of a negative number. So x equals negative 6 is an extraneous solution. So our only solution here is x equals positive 6. All right, and then number 10. Let's see. Log base 2 of 2x minus 1 minus log base 2 of x plus 5 equals 1/2 log base 2 of 36 minus 2 log base 2 of 2. All right, so I need to condense both sides. So I need to condense the left and condense the right into a single logarithm. So the first thing I'm going to do is take this 1/2 as an exponent and put it up on the 36 and bring the 2 up as an exponent. So 36 to the 1/2 power is 6, because 1/2 is like saying the square root to the first, if we bow tie that. Minus log base 2 of 4. Now remember, subtracting means to divide, so I'm dividing 6 and 4. So I'd get log base 2 of 6 over 4. You can reduce it if you'd like. You don't need to right now. Ooh. Should have started a new page because I'm running out. All right, same thing on this left side. There's no exponents to move up, but the subtraction means to divide. So I'm dividing 2x minus 1 and x plus 5. So log base 2 of 2x minus 1 over x plus 5. And now here we can drop the logs. I'm going to kind of squish it over here in the corner. So I have 2x minus 1 over x plus 5 equals 6 over 4. Now to solve this, we would want to cross multiply. So I'm going to multiply 4 and 2x minus 1, which would give me 8x minus 4. And this is going to equal, when I multiply 6 times x plus 5. So I get 6x plus 30. And then we'd want to get the x's by itself, so subtract 6x from each side. So 2x minus 4 equals 30. Add 4 to each side. So 2x equals 34, which means x equals 17. All right. So this is type 3. They could be really easy. They could be more complicated because we have to use all of our log rules on them. And then our last type, type 4, are equations that don't involve your normal logs. They involve e or natural log. Now, e and natural log are inverses. So we're going to use one to cancel out the other. I also just realized that I labeled these 9, 10 again, when this should have been like 11, 12. And I went back to see what number we were on. So 13, let's do 2e to the 4x minus 1 equals 15. Now, similar to our exponents, we want to get this e to the 4x by itself. So the first thing I'm going to do is add 1 to both sides. And then to get the 2 away, I'm going to divide each side by 2. To get e to the 4x equals 8. Now, to cancel out the e, we are going to take the natural log of each side, because natural log and e are inverses. So this would cancel out here. So I'd end up with 4x equals the natural log of 8. And then I'd divide by 4. So I get the natural log of 8 over 4. So when you stick this in your calculator, do the natural log of 8 first. Which should be approximately 2.079 over 4. So x equals 0.1520. And then we'll do one with a natural log, and we will call it for the day. So let's do the natural log of 3x plus 2 equals 4. So here on the left, the natural log is already by itself. So to cancel out natural log, we use e. So on the left side, e and natural log will cancel out. So I'll just have 3x plus 2. And this will equal e to the 4th. And you can stick this e to the 4th in your calculator. E to the 4th is 54.598. And then we would subtract 2 from each side. and then divide by 3. So x should equal about 17.533. All right, so kind of a longer notes today. I apologize. But that will be all for today. Have a good one.